Aloha, lesson 9, video 2, of course, module 6, grade 5, and here we are in your Learn book on the magnifying glass page for lesson 9, and you have a chart that looks like this, a table, a chart, and we have x coordinate 1, y coordinate 2, ordered pair 1, 2, x coordinate 3, y coordinate 6, ordered pair 3, 6, x coordinate 5, y coordinate 10, ordered pair 5, 10. Thinking about the patterns that we see there, we see that our x's are showing one pattern and our y's are representing another pattern. How could we determine our next 3 x coordinates? Maybe you already did. What did you do there? Let's add 1 plus 2 is 3, 3 plus 2 is 5, so 5 plus 2, 7, 7 plus 2 is 9, 9 plus 2, 9, 10, 11. Very good. And what about here? What is our pattern? 2 plus what equals 6? 2 plus 4 equals 6. Let's just double check it. 6 plus 4 equals 10. So 10 plus 4 is going to be 14. 14 plus 4 is going to be 18. 18. 2 makes 20, and then 2 more makes 22. Okay, so adding 2 and then adding 4. How is the graph of these points similar to the graphs we saw in the previous lesson? Did you graph them yet? Okay, let's look at a graph. So let's see, I can keep my, I didn't write my ordered pairs. Did you write your ordered pairs? 7, 14, 9, 18, 11, 22. Okay, and then let's graph them together. Sorry, just trying to get my ordered pairs on the screen so we can kind of reference them as we're going. There we go. 1, 2. So 1 to the right, 2 up. Yes, 1 and 2. Very good. 1 to the right and 2 up. 3, 6, 3, 6. Okay, and we notice that our graph has every other number listed, but it is counting by ones, except that it's only showing 2, 4, 6, 8, but the line in between would be the ones, right? Okay, so 3 would be between 2 and 4, and then up to 6. Okay, so we can see that our line is going to be pretty steep because we're going across 2 and up 4. So let's go 5 and up to 10, checking very carefully, making sure that we're doing it right. 7 and up to 14. There we go. And 9 and up to 18. Double checking that they're in a line. That's going to help. And 11 up to 22. 11 all the way up to 22. Okay, looking pretty good. So how is this graph similar to the graphs we saw in previous lesson, and how is it different? What do you notice? It's collinear. They're on a line, right? Using one of those words that we learned earlier. They are collinear. So they're forming a line. A little bit different that we're going across 2 and up 4. In the past, our patterns were the same, and now we're having patterns that are different, right? Instead of them both being adding 2 or adding 4, we have one that's adding 2 and one that's adding 4, which means that our corresponding points, we have a different pattern here, right? Like we talked about in the beginning, we're going to have a little bit of a different pattern. So our adding 2 rule is showing right here, right? Adding 2, and then our adding 4 rule is showing right there. Do you see that? 2 across and 4 up. So that's how we see it. Adding 2, adding 4, adding 2, adding 4. Interesting way to look at the table and then look at the graph. Okay, now what if we had an x of 25, what would our y be? And how do you know? Let's go back and look at our table. If our x is 25, what is our y? Do you notice any patterns in the table? Before we were looking at addition patterns, but the title of this lesson is Identify Multiplication and Division Relationships. Do you see any multiplicative or multiplication patterns? 1 times 2 is 2. 3 times 2 is 6. 5 times 2 is 10. 7 times 2 is 14. Okay, so we're multiplying by 2. Is it working? Yes, every time we're multiplying by 2. So 25 times 2, our y would be 50. Right? And hopefully you know that because 2 quarters in money makes 50 cents, right? 25 cents. 25 cents makes 50 cents. Okay, so we're multiplying by 2. What if we knew our y-axis but not our x? We could just divide by 2, right? 50 divided by 2 is 25. 22 divided by 2 is 11. 18 divided by 2 is 9. All right, excellent. Could we just have counted all the way up? Yes, but we can multiply, right? We don't want to take all of our time figuring it out. Okay, very good. Excellent. How can we use the relationship between coordinates to generate or make more ordered pairs? So what would, if our x was 13, which would be the next one, right? Because we're going up by 2, skipping the 25, of course. Then what would be our y? We could multiply by 2, so that would be 26, right? So we can use that pattern to generate coordinates. All right, so what if our x is 35? You might have to write it down, right? 35 times 2, 6 plus 1 is 7. Nothing wrong with multiplying. 70. Very good. Ooh, what if our y is 102? Can we do 102 divided by 2? Oh, sorry. Helps if it's on the screen, right? There we go. 50 would be 100. And 2 would be 1, so 51. Yes? All right. Fabulous. All right, let's look at another graph. Sorry, another table. Okay. We're just going to be looking at this table. And we also have a coordinate grid that goes with it. I think it's on the next page. There we go. We are going to observe our table and our coordinate grid. What are the rules for the x and the y axis? What do you notice? What are the rules? X to y. What are we doing? X to the next x. We are adding 3. Does that work for everyone? Yes, adding 3. How about from y? Adding 1, right? Adding 1. Yep, it works for everyone. Okay. Where can we see these rules in our graph? Adding 3 and then adding 1. Do you see it? Adding 3, adding 1, adding 3, adding 1. Yeah, so it's going 3 across and then 1 up. 3 across and 1 up. Okay, very good. We add 3 times as much to the x coordinates as we add to the y coordinates, and we move 3 times as much to the right as we move up. You hear the words 3 times as much, right? So the relationship between the x and the y, the x is 3 times as much. So if we're going to go this way, we'd have to divide by 3. And if we're going to go from y to x, then we would multiply by 3. Because it's 3 times as much, and you see it right here on our coordinate plane, 3 times as much. Our x is 3 and our y is 1 every time. 3, 1, 3, 1. That's pretty cool, isn't it? I kind of like it. So what if our x coordinate was 60? What would our y coordinate be? Now remember, our y coordinate is less, 3 times less, so 60 divided by 3 is 20. And what if our x coordinate was 60? Then our y coordinate would be 3 times more, 180. Yes? Okay, very good. In the next video, we're going to be working on question number 2 in your Learn book with the magnifying glass. I'll see you there. Thanks for your hard work. Aloha.